what a timely way, given all that we've talked about, to end on a note where we're talking about what does the next internet look like? And how do we go from an electronic heat creating communications network to an all photonics low energy network? Those are the big questions that are driving NTT's IOWN initiative. And you heard from our beginning this morning talking about the IOWN initiative. Please welcome our NTT's R&D Head of Planning, Atsuko Oka, who's going to share the roadmap to scaling in a sustainable, smart world. Please join us.
Okay. Hello, everyone, and welcome to Research Inc. This is my first time to come here, too. And this is my first trip to the United States since the outbreak of the COVID-19. In Japan, many people still wear masks. For the past 3 years, I have been giving the speeches to people wearing masks. Today, I can see everyone's faces. So it is a very different experience, but I'm very happy. So it is an honor to share our plans with such knowledgeable audience. Today, I would like to introduce the IO initiative that NTT R&D aiming for. First of all, let me introduce our company and the laboratories. NTT has 4 development centers and 10 laboratories in its holding company, and 3 laboratories in NTT Research Inc. A total of 2,300 researchers are working in various fields, ranging from human science to information science, data science, and networking, environment, energy, and quantum science. NTT is well known in Japan as a telecommunication company. NTT stands for Nippon Telegraph and Telephone. However, these revenues are only a part of NTT's overall revenues. NTT is actually engaged in a wide variety of businesses, including system development, urban development, and energy business. One of our R&D mission is to support these broad business areas with technology. Therefore, our R&D efforts are also diverse. Now, one of our major business is data center colocation. Our global market share in terms of revenues currently ranks 3rd. NTT is one of the front runners in this field. The data center market will grow significantly in the future. Until now, the data center business has focused on the United States and Europe, but in the future, many reports expect significant growth in Asia, especially in China and India. Yes, NTT already has many data centers in India. However, we have a big problem within this business. Data center consumes a lot of energy, and power usage is expected to increase rapidly due to the exponential growth of data generated by IoT devices and AI-powered business applications. In short, it's not sustainable. So we need an innovation. High-capacity networks and energy-efficient technologies are necessary. We must address these challenges to ensure the sustainable growth of this critical industry. In addition, there is another important requirement for the future. That is low latency. The total latency of communication and data processing must be short. There are more use cases where low latency is essential. These include the control of mobile devices, such as vehicles and drones. VR systems and metaverse systems also require low latency. Our answer to all these problems is IOWN, innovative optical and wireless network, and that is the topic I will talk about today. Within IOWN, we aim to improve power efficiency, processing capacity, and low latency in order to meet the numerical targets shown here by 2030. Next, I will give an overview of IOWN. In short, IOWN is a concept for creating smart worlds. In IOWN, optical networks and optical computing are used for this purpose. Many things such as mobility, drones, and robots are connected to data centers through optical networks and optical computers. This will pave the way to realizing smart worlds, featuring smart mobility, smart factories, and other smart activities. This is the basic concept of IOWN. By the way, why do we use the light? Light is much more efficient than electricity. As you know, the optical fiber is better than metal wire. Higher frequency light is even more advantageous for transmitting large amounts of data, and light is superior to electricity in this respect as well. As data continues to grow, using higher frequency light for even shorter distances is more efficient for transmitting more data. Therefore, NTT is developing optical devices to convert light and electricity at high speed. Currently, we are developing devices for ultra-high speed and high-capacity switches and network interface cards for PCs. We are also doing research of next-generation devices that will be used inside computers. The network of IOWN is the all-photonic network, or APN. Conventional networks have many conversions between optical and electrical signals in the network, which is like having many traffic lights on an expressway. The car stops every time at the switches. Despite having optical fiber as an expressway, traffic lights remain and impede fast communication. The ideal solution is to build a true expressway. APN is an end-to-end optical network where signals can travel at the speed of light. All processes such as routings are done by light. Let me introduce the use cases of APN. The first one is remote performance. Let me present a video.
いやもう本当に映像と音の遅延に関してはほとんど感じられないようなレベルになってると思うし、その映像をこう4つの地点の映像を集めてこうあそこで1つに流すっていうのも体では感じないような、普通にこうやり取りをしてるようなレベルでできたので、すごいなというふうに思いました。
So since they are professional musicians, they did not show their poor performances to the public, but they could not perform at all on ordinary internet connection. Okay, So next, I would like to show the second use case, the remote operation of surgical robots. Because of ultra-low latency, the robots move at the moment of operation, even if being operated from a long distance. It is very easy to operate. In addition, it is possible to send an ultra-high quality video in real time. This is also very important for accurate surgery. I think that APN will change the relationship between doctors and patients. You will not need to go to see a particular doctor. A great surgery will be available even in small towns. I believe such future will come. Furthermore, precise remote control of robots opens many doors. APN will be utilized in a wide range of fields. The third use case is finance transactions. The finance industry has a speed competition for fast trading because stock prices can change quickly. So the exchanges want to provide a fair competitive environment, but current networks are best effort and unfair. APN provides a fair environment. Since the speed of writing is constant, the transmission time is determined once the distance is decided. This allows you to tightly control the delay time and to ensure the same delay from each location, achieving fast and fair competition. The next topic is how to make the APN. It is easy. Just connect APN products by optical fibers. The products are already on the market. All you need is to connect these devices with optical fibers. Okay, let's get back to the topic of data centers. Now, one of the APN's primary business targets is interconnecting data centers. There are many data centers, mega clouds, on-premises environments of various companies, and network data centers. NTT aims to connect all of them with APN. The reason is to create smart worlds. Mobile networks are fast, but connections to data centers are slow. Communication between data centers of different companies is also slow. As a result, web service integration becomes slow and data exchange is also slow. As I mentioned at the beginning, we need ultra-low latency. So we will connect all data centers, including mobile networks, with an APN. That makes it possible to control mobile devices such as mobility, drones, and robots in real time from a data center using AI. For connecting all data centers, the APN is best solution. Some data centers are currently connected by optical fibers, but they are meshed together. In this method, if you want to connect a new building, you have to connect with all other data centers. It's very costly. That's where APN comes in. It's very easy. Just connect an optical fiber to an optical switch of APN. This method is very suitable to connect all the data centers. Fortunately, most major data centers are concentrated in or near large cities. This trend is observed in various parts of the globe, including Tokyo, London, Paris, New York, and San Jose. The underlying reason is the lack of human resources. In small towns, it is difficult to hire engineers. Hence, our initial action is to establish the APN within the metropolitan area. This is also advantageous in terms of business strategy. Today, I have talked about IOWN. IOWN technologies are discussed in an organization called IOWN Global Forum. Currently, 117 companies and organizations participate in the forum. A characteristic of this forum is that many non-technical companies participate in it. The reason is that the forum discusses use cases before discussing technologies. There may be people here who are not engineers. Many complex technologies are used in the IOWN, but please don't think that is irrelevant to you. The essential question surrounding IOWN is, what is a smart world? What kind of world do you want to create? That is why we need your ideas. We need strong partnerships. I like to encourage as many people as possible to participate. Finally, I have a big announcement today. NTT launched an APN service in Japan today, March 16th. It's a Memorial Day. You are among the first people to hear this news. The use cases I introduced today will be launched or tested in Japan ahead of other countries. So let's create the future together. Thank you very much.